All right. Very fast. It's going to be quite fast. So I need you to be on board with me. It's going to be quite fast as requested. To look at a few questions that I sent earlier on and you play around. Most of them are just similar concepts, so we move very fast. A 9 kg box which is held, please make sure you read carefully. A 9 kg box is held at rest, okay? The fact that they talk about 9 kg, we know that that's the mass and that refers to the weight. All right, rest on a rough. We're going to talk about what a frictional force there. All right, horizontal surface. We talk about normal there. Okay, remember mass. We talk about the force of gravity pulling that. All right, it's connected by a light inextensible string. That tells me there's tension over a light frictionless pulley to an object of mass 2,5 hanging vertically. When the box is released, a frictional force of 6 Newton acts on it. Okay, so we do know friction here, which is what? 6 Newton. And obviously, it's going to move to the right. State Newton's second law of motion in words that I'm going to pass. All right, when a net force acts on an object, the object will accelerate in the direction of the net force. Acceleration is directly proportional to net force and inversely proportional to the mass. Label free body diagram on the 9 kg. Okay, so what other forces we have? But should I lose you, please do not hesitate to let me know. We have the weight, we have the normal, we have the tension force, which is pulling that object this way, and we have a frictional force that way. Remember, all must be coming from the dot, so make your dot bigger. What is this? Force of gravity. What do we have on the right hand side? We have tension, which is obviously longer because the object is now moving. And what is this? This is kinetic friction. And we have normal force. You get your full 4 marks there. Calculate the magnitude of the acceleration of the object. Now, let's go check. Object is moving to the right. So we take that motion as positive. So I'll come here and say F net is equal to MA. Remember, if the object is moving horizontally, vertical forces are balanced. All right. So it's going to be tension plus negative friction equals to MA. All right. Tension minus friction. That's what I have now. But do I know my friction? Yes. What's the mass? 9. Do we know acceleration? No. Okay, so we have T minus 6 equals to 9A. My dear learners, already we see that we have 2 unknowns. We've got to work with the second object. To make life, we need to draw a free body diagram. Always draw of the second object too. All right, which is only having 2 forces acting. The weight is acting downwards, which is Fg. There's no normal this time around. It is tension. Remember, we chose this direct. The object is moving this way, positive. So it goes down, which means my weight is positive, and that is negative. So we can create our second equation. I'm trying to squeeze everything right on one page. Our second equation will therefore be F net equals to MA, but it is now Fg is positive plus our tension, which is negative. All right, mg, what's our mg? 2,5 multiplied by 9,8 minus t equals to 2,5a. I hope everybody's okay. Now, what is 2,5 times 9,8? You need to work with me and give me those answers as fast as possible. Sitley, your hand is raised. 24,5. Thank you. So 24,5 minus t equals to 2,5a. So we need to get acceleration. We have 2 equations. Guys, I want to just eliminate because I see tt there. All right, minus 6. I'm just rearranging this plus t equals to 9a. So these are the two equations that I have. Grade 10, I want to use elimination method. I can just add equation 1 and equation 2 because the t's will just cancel. So what is 25,5 minus 6? You got to work with what's comfortable for you, but I need us to learn quick work as well. 24,5 minus. So we're saying we're just subtracting the equations because the t would cancel. Anybody giving me an answer there? This one would give me 11,5a. What is 24,5 minus 6? That's 18,5, I think. Please talk to me. $18,5, right? So 24,5 minus 16. All right, 18,5. What is your A therefore? We divide by 11,5. Somebody's giving me an answer? Answer, please. This one is an easy peasy, question. All right, I'll wait for you. (1,61). TK says 1,61. Are we confirming? Sitley, thumbs up means you agree. 1,61. And what's our unit? Our unit is meters per second. All right, squared, acceleration, 1,61 meters per second squared. That question is done. Took us about 4 minutes to get that done. Sweet. I hope that's fine. All right, look at this one. 2 blocks P and Q resting on a rough, again, you got to read, all right? Rough horizontal surface are connected by a lighting extensible string. Check all the things I underlined earlier on. The blocks have masses 5 kg and 2 kg respectively. A constant force F acting at an angle of 30 to the horizontal is applied to 5 kg as shown in the to the 5 kg block as shown below. The 2 blocks move to the right at constant speed. Okay, take note of that. Constant speed. Acceleration is equal to 0. State Newton's first law in words. You don't have to just focus on second. You must know all your laws. Okay? You must know all the laws. An object will remain at rest or continue in uniform motion unless acted upon by an external or unbalanced force. I'm going to 2.2. All right, on P, what do we have? What are the forces acting on P? Remember, you draw out of the box, out of the dots. That's my force applied, please. You don't draw into. I have my normal because the object is on the surface. I've got a weight there. All right. Object 2 kg is pulling. So there's tension. The object is being pushed to the right. So friction must be to the left. And there we go. And that's how things are done. Now we label force of gravity, which is also known as the weight, if you like. What is this? Force applied. What is that? That's your normal force. What is this one? Tension. And what is this? Friction. Once you get your free body diagram right, guys, things will be okay. But before you calculate, let's quickly fix what the problem would be. The problem would be my force applied. I need to change that force applied into something that I can work with. And you know what that would be already. All right, that's my normal. Everything remains the same. Okay, now I can just write symbols and, Okay, now what would I be having? I'll be having one to the right and one downwards. I hope it makes sense when I say it downwards. Okay. Then that's the big dot there. Make sure every force is touching the dot. What is this? FG. FY, because it's pointing down right. And that's FX. That's normal. That's tension. You must be able to do this. And if I go back to my diagram, which I like to do all the time, I complete my diagram there. Oh, I see. It is the vertical that is opposite the angle. And the one that is opposite, we use what? Sine. So basically this is F sine 30. And this is F cos 30. Lovely. That is done. Now, we want to calculate the magnitude of force F. Oh, let's go check. Check first before you check if you need the order diagram. F net equals to MA. Object is moving to the right. So, go back to my working diagram. Positive, negative, and negative. Sweet. What do I have? Fx, which is F cos 30. Alright, the other ones are negative, minus T, minus Fk equals to MA, which is 0 by the way. F, we don't know F. We do not know tension. But do we know friction? I think we do. Yes, box P and Q experience what? Constant frictional force of 2,5. Alright? And 1. P, which is my 5 kg, friction is 2,5. Alright? Mass is 5 and the acceleration is 0. Oh, so what do we know? F cos 30 minus 2,5. That's my tension. We are stuck there because we have two unknowns. Let's go now look at the second object. That's where we're going to get our answer from now. I'm going to draw my free body diagram right on by the 2 kg. So what do we have? Object is being pulled to the right. That's tension. All right? There we go. Object being pulled to the right. Tension. Okay, guys, are we sharing the link? Okay, please. We're not sharing the link. Not sure who I just got into class right now. All right, friction there, tension. And we have our normal. All right, this is just to quickly guide us. And FG. Object is moving to the right, so that's positive and that's negative. So the second object, now what do we have? F net equals to MA. T minus friction equals to MA. Oh, our friction we know is 1. And this is 0. Do you know what 0? Acceleration is 0. If you want, you can still substitute your mass, but it's of no use. T equals to 1. Oh, can we then bring that in? Lovely. So F cos 30 minus 2,5 equals to 1. F cos 30 equals to 1 plus 2, can I just two shortcuts there? That is 3,5. So what is F? 3,5 divided by cos 30. Let's see, because I remember the answers you gave me yesterday. Over cos 30. Okay. 4, was this the answer you guys gave me yesterday? (4,04). Was this the answer you all gave me yesterday? Yes. Okay. So what was wrong with what you did yesterday? Because I'm going back to check your messages now. Okay. Sikulile, because you guys use the 3. Remember, the 3 is velocity, but we are working with acceleration. Okay. So I hope we've corrected that, taking note of that error, and that won't happen. Okay. I hope that's okay, everybody. Google, we okay? TK, Tovelo. Tsejo. Chabulile Pewa. No, it's not FS, because the object is that the 2 blocks now move to the constant speed. Did you see that statement there? The objects now move to the right at constant what? Speed. Okay. All right. Now the string connecting P and Q suddenly breaks. Okay. While F is still being applied. Is the direction of the acceleration of Q now towards left or right? So the string breaks, so there's no more connection to P. Okay. Now we know that the only force, remember there were 2 forces, tension and friction. But if we then remove tension, it means the only force that will be acting is friction, which is to the left. The object will accelerate in the direction of the net force, which is left. I hope that makes sense. Once the string breaks, the only force present is the force of what? Friction. So you've got to use Newton's second law to answer that. Let me give you step-by-step way of answering that. 1 second, just trying to change this board. Okay, so we're going to say that the only force, which is 2 point, what is that? I don't even remember. 2.4. The only force acting is friction. Okay, so object will accelerate in the direction of the net force, which is to the left. And you have already answered to the left. 3 marks, I think. 1, 2, and the acceleration part, 3. All right, everybody okay? All right. How will the net force acting on the block P be affected? Choose increase, decrease, or remain the same. The net force, the string is now broken. All right? The string is broken. You can always use your free body diagram to check. The net force was the positive 1 minus the negatives. Now we are removing 1 negative. We are only left with 2. Definitely it will what? increase. I hope it makes sense, because we are removing a force that was pulling it in the opposite direction. All right? I hope that makes sense, everybody. And we are done with that question. So please, let's take note. I saw your mistake was you were using the 3. The sketch below is a setup which can be used to determine the gravitational acceleration G. 2 different masses MA and MB are attached to a light inextensible cord which hangs over a frictionless pulley. As shown in the diagram, the masses are initially at rest. Okay, so we see MA and MB. Ignore the effect of friction, masses of the cord, and the pulley. State Newton's third law. You see now that in the 3 questions we've done, one asks for the first, one asks for the second, and the third one is asking for the third. So it's important that we know all the 3. All right. When the masses are released from rest, the system moves through a vertical distance of 0,50 in 1,43 seconds. Draw a labeled free body diagram for mass A as it moves upwards. Okay. As it moves upward. Now, let's check something here. When they are released, do you notice that B is heavier? So what happens? B is going to go down while A is going to move what? Upwards. Which forces are acting on it? It's going to be the force of the rope, tension, and gravity. Force of gravity and tension. We are done. 2 marks. Calculate the value of the gravitational acceleration G. Okay, so we are now looking G. All right, let's see something here. On the B, okay, this one is A, right? Let's draw for B. What are we going to have? We're actually going to have the same forces, right? Oh no, what am I doing? We're going to have the same forces, okay? But this time around, our gravity would be heavier than the tension. And this is gravity. Since it's moving down, let's choose down as positive. So positive, this will be negative, this will be positive, and this will be, I hope it makes sense. It's making sense because it's going this way. We're choosing that direction of motion as positive. All right. Now, we were told that when the masses are released from rest, the system moves through a vertical distance. So let's write what we know. We know our vertical distance of 0,50, and we have a time of what? 1,43 seconds. Okay. The question now is, how do we then get our... Guys, don't say you know G. We don't know G. But what can we get from this equation that we have? We obviously can get the velocity, all right, which doesn't give us acceleration, by the way. We want acceleration due to gravity. Okay, so we can actually get, since we know the distance, check. We know this, we know that. And we already know our initial velocity as 0 because the objects were moving from rest. So write everything you have. If I say F net equals to MA, my dear learners, I do not know A. But can I get A first? Lovely. With my equations of motion, I know that delta Y equals to VI delta T plus, can we use this? This is one equation. Yes, we can because we have everything. What's our delta Y? 0,5. What's our initial? 0. We don't know time. Remember, this is not G. This is A. And what is our time? 1,43 squared. Okay, if I divide both sides by 2, what would I have? That would be 1 equals to a 1 comma 43 squared. Divide both sides by that. 1 over, do you want to give me an answer here quickly? Or we can keep it like this so that we don't round off. I hope, let me just check with you first. Guys, is this first step okay with you? Is this first step okay with you? All right. Now we can go. Why am I using this? Because I need that acceleration. Now let's go for F net equals to MA now that we have our acceleration. So F net, let's deal with the A. If you check the A, which one is positive? Tension. So T minus mg equals to MA. T minus, what is our M? 1,9. Okay, remember we cannot substitute G this time around. We don't know it. 1,9, 1 over 1,43 all squared. That's our acceleration. Remember, 1 over 1,43. Okay. Trying not to round off so we get something perfect. We have two unknowns, T and G. So, but I'm sure we can give me the value on the right hand side so that we have to just do, let me get a calculator to make it fast. Where is it? There we go. So 1,9, all right, multiplied by 1 over 1,43, all what? Squared. All right, we have 0,9291. Okay, so we don't round off early. 0,9291. That's our first equation. So let's go check the one for B. Look at the diagram. Our gravity is positive this time around. All right, so what do we have? mg minus t equals to ma. What is the mass? 2,1. So 2,1 times g, all right, minus t equals to 2,1, 1 over 1,43, all what? Squared. 2,1 g minus t. Calculator quickly. Let's see. So 2,1 into bracket, 1 over 1,43, all squared. Remember, I'm just using math now. 1,0269. 1,0269. 1,0269. Check. We now have two equations. We have equation 1 and we have equation 2. We don't need to calculate tension, guys. Okay? If you want, you can use your substitution method by saying T from the equation 1 will be equal to 0,92914 plus, you just trust the process, all right? And from equation 1, T, you see, if I bring the T to the right, I'll be having 2,1 G minus, I hope I haven't lost you. So many methods, 0,269. Okay, so I looked for T on both. Either you do that or you just eliminate. But since both of them are equal to T, I can then, I think we are almost at the last step. This is just now simple math. You see, I'm using 4 decimal because I don't want to round up. All right? Okay. So what do we have? 2,1 G minus 1,9 G. Guys, please, I think we are sharing this link because I'm seeing a lot of people that I don't even know. 2,1 minus 1,9 would give us what? 0,2 G. Do you want to give me an answer? Everybody just get G for me. Quickly get me G. Get me G quickly. You do the maths now. You got 9,8. Google is giving me 1,96. Are you giving me the final answer? (9,8). All right, so which is a perfect answer? G equals to 9,8. It couldn't be more perfect. Couldn't be more perfect. All right, so you trust the process and walk through. Okay, you will be able to catch up on this lesson later because I need to run through as fast as possible. All right, so that's the whole question. Beautiful question, beautiful process as well. 7 marks, quite interesting. Oh, universal gravitation. Once every month, a new moon is observed when the Earth and the moon orbit the sun. When this happens, the three bodies line up as shown in the picture below. During this period, the moon experiences a net, take note of the word, a net zero. All right? A net zero gravitational. When we use the word net, it means we need to add together. All right, take the mass of the gravitational force of attraction. Calculate the distance between the centers of the sun and the moon during the new moon. Interesting. So we have the mass of the sun, we have the mass of the moon, we have the gravitational force of attraction between the moon and the earth as that. All right. It says, let's quickly analyze something here. It says the moon. Oh, lovely. The moon exact. Now, remember, there is a force of attraction between all these objects. So, the moon is being pulled. Check this. The moon is being pulled towards the sun, but the moon as well is being pulled towards the earth. So, let's call this F of the earth, and let's call this F of the sun. But it says the net, it experiences a net gravitational force, which means F net on the moon is equal to 0. I hope that makes sense. F net on the moon. Oh, so we are saying if we choose this as positive and negative, it can only happen, therefore, that Fs plus negative F of the earth on the moon is now 0. So Fs minus Fe. Oh, so the forces are actually the same. That's why the moon experiences a 0 force. So we are looking for the center of the sun. And so let's focus on the sun and the moon now. Oh, if we are focusing on the sun and the moon, the force of attraction between them, you remember your formula? It will be G M of the sun, okay, Fs, over the distance between their centers squared. Now, we are given a force of attraction between the moon and the earth, which is this one. Oh, but we said it is equal to that. Oh, that is so now nice. So nice. So our Fs equals to Fe. which is equal to 1,997 times 10 to the power 20 newtons. Can we just do the substitution? 1,997 times 10 to the power 20. I'm sure you remember what your G is. If you do check your data pages, please make sure you have that formula. Don't write it from your head. Your head is too small to remember that number. But the more you walk through physics, you get familiar to those numbers. Please check your formula page and let me know if you found it. Let me know if you found G. Go and look for it. You'll be finding 6,67, right? So you see it. 6,67 times 10 to the power negative 11. Do we know the mass of the sun? Oh, we were given 1,99 times 10 to the power. Okay, my space is now very small. But you can all see what I am trying to do. I am only trying to do my substitution now. Let me do this. Let me reduce this. Okay. I've done all my annotations, but let me put this there. So f of the sun and f of E. So we have said f of S is equal to Fe because F net is equal to 0. So what is my force of the earth? 1,997 times 10 to the power 20. G is 6,67 times 10 to the power negative 11. What is the mass? Drop this a little bit. What is the mass of the sun? We were given 1,99 times 10 to the power 30. What is the mass of the earth? Okay, the mass of the earth is, I don't know, why are we looking at the mass of the earth? It's the sun and the moon. Sorry. It is the sun and the moon. Mass of the moon is 7,35 times 10 to the power 22 over D. And that's what we are looking for. Look, mathematically, let me teach you something here. You can just swap these figures. All right, just swap those figures. And to save time, just quickly going to do that. What do we have? 6,67 times 10 to the power negative 11. All right, times 1,99 times 10 to the power 30 times 7, please also, you know that you're supposed to be pressing your own calculators as well to make sure we have the same answer. I am swapping those values quickly. 1,997 times 10 to the power 20. But I need to find the square root. All right, please confirm 2,21. That is what I have. Please confirm. 2,21 times 10 to the power 11. You have 215. How did you get 215, Sitley? I've got 210. Yep.
On my table of constants, the G is 6,7.
No, it's 6,67. Use the one in the question paper. Yep. So 2,21 times 10 to the power 11 meters. And that's it there. So they are bringing, the question is actually again testing your Newton's laws, knowledge of Newton's laws. F net being 0. And that's the same thing you're going to do when you get to electrostatics. All right, so that's it there. And that's done, dusted. Let's check this one. A spaceship of mass m leaves planet A and sets out into space towards a newly discovered planet B, as shown in the diagram. After traveling 60% on the way to planet B, the commander discovers the net force of the two planets on the spaceship is 0. Same statement like where the question we just did. All right. Same statement. This one is 60% of the way to planet B. Okay. So the total distance is r. So this is 0,6 r. I hope you got my 60% is 0,6 of the distance. And this distance, therefore, is 0,4 r. Give a reason why Newton's law of inverse square. Oh, okay. Because the force is inversely proportional to the square of the distance between the two objects. Distance between the centers of the two objects. Alright, that's why it's called an inverse square, because it's inverse proportional to the square. So basically we're saying F. Okay. Show by means of an appropriate calculation that the ratio of the masses of the two planets is given by MA to MB. Interesting here. Let's see. Okay. Now, it says again the net. Once it says net, understand that we're working with both sides. All right. So, A on spaceship. So, if we say the F net, therefore, is 0, it means the F of A on the spaceship should be equal to the F of B on the spaceship. Just like we did earlier on. What is F, by the way? It is G. Now, for F, A, G, MA, mass of spaceship over the distance squared equals to G, MB, spaceship is our focus, over the distance squared. Interesting. Let's see. Divide both sides by G. Okay. G would divide. MS, mass of the space, is also equal. So MA over D squared equals to what? MB. All right, let's see. MA, what is the distance squared? It is 0,6 r. All right. But it is all squared. Distance of A. What is the distance of B? It is 0,4 r. Okay, this is looking interesting. Let's see where it's going to lead us. All right. Since we are looking for MA over MB ratio, cross multiply and divide. MA, if I'm bringing my MB here, it is going to divide. If I take my 0,6 that's dividing here, so it's going to multiply. No. What am I doing? 0,6 r all squared over 0,4 r all squared. What will this give us? The r's can go. What are we going to have? 0,6 squared divided by 0,4 squared. That will be 36 over 16. Let's see. Let's just make it fast. Use a calculator. Squared. 0,6 squared over 0,4 squared. 9 over 4. Done. And that's it there. Easy peasy. All done. Are we okay, guys? Are we okay? So it's just a matter of understanding the concept. It's a matter of understanding the concept. Please let me get your responses as quick as possible. All right. Sitley said it's okay. TK, Google, please talk to me. All right, so that's how we get things done. Read the question, write down what you know. Question based on the concept you're dealing with, and life becomes quite easy. All right, let's quickly check this one. We have just about 30 minutes. Two blocks of masses 1,5 and 3,2 are connected by a light inextensible string. A 24 Newton force is applied on the system of blocks and moves up at inclined surface of 25. All right, there's a mistake. There's 25 there, and I'm looking at the diagram. I see a 20. Okay, we're just going to decide on which one to work with. Let's work with the diagram 20. Okay, I see that as an error there, 20. Okay, constant velocity, again, acceleration is equal to what? 0. The 1,5 experiences a constant frictional force of 2 newtons as it moves up the incline. Let's see. Draw a labeled free body diagrams of all the forces acting on the 1.5. Do you see I've skipped 4.1 because I know now that you know what to do. So our normal force is that way. Our gravity is this way. The 1,5 is being pulled up by tension. If the object is going up, friction must be acting in the opposite direction. So let's label quickly. What is that? Force of gravity. What do we have there? We have our tension, we have our friction, and we have the normal force. You get your quick 4 marks there. But remember what we said. Don't leave without quickly drawing what will help you to calculate. Our normal is going to go that way. FG perpendicular would go that way. That's very, very important, my dear learners. FG perpendicular, which is mg cos theta. All right. Just move this a little. Now, FG parallel. Parallel must always be down, but parallel to the surface. The surface is that way. So, FG parallel, which is mg sine theta. Now, what do we have here? We have normal. Where's friction? Oh, friction is that way as well. And then we have our tension that way. Once you are able to do this quickly, life becomes easy. So before you calculate, just quickly get that out of the way. Take upward as positive, that will be negative, negative, and negative. Do all the analysis before you even start calculating. Calculate the tension connecting the blocks together. All right, let's see. Where do we have lot of information? Let's see, we're looking for tension. Okay, let's go check on the 1,5 because that's where we're starting from. So F net equals to MA. What are the forces? Tension is up there, plus negative friction, plus negative FG parallel. Life is now easy. MA. We are looking for the tension, right? Lovely. Do we know the friction? We do. It's 2 Newton. We're given minus mg sine theta. I can just throw in my mg sine theta there. What is the mass? 1,5, 9,8. We're working with the diagram, sine 20. This is equal to 0. I hope you understand why it's equals to 0. Acceleration is 0 at constant velocity. So what do I have? Negative 2, all right, minus 1,5 times 9,8 sine 20. That gives me that. If I take the whole thing over, then it gives me what? A positive. So what do I have? 7,03. Please confirm. Confirm with your own calculator. Remember, that's what we do. Confirm quickly. That's what we do. Necessary for everyone to work through. All right, that's what you also have. Thank you. So our answer therefore is 7,03 Newton. Done. 5 marks. Sweet 5 marks. Calculate the coefficient of kinetic friction between the 3 kg. All right. We cannot get coefficient until we get friction. So let's go draw the free body diagram of the 3 kg. Let's draw the free body diagram. Okay. So this is my 3,2 kg now. What's going to happen is this is no longer tension. Oops, I didn't want to erase the whole thing. This is no longer tension. This is now my force applied, which is 24 newtons, remember? Oh, I could just work with this diagram since, I could just work with this one. Let's work with this one quickly. All right, so like we said, it is no longer tension up there. It is now the 24 newtons. Now, where's my tension? My tension is now towards the 1,5. So that should go that way as well. Let me take it up for clarity. Should they ask you for the free body diagram, make sure it's parallel, and then you have what? Tension there. All right. So we know our tension is 7,03. Let's get friction first. Let's get friction. Let me clean all of this. We want friction. Just want a clean board. There we go. Now, if we want friction, again, F net is equal to MA. All right, what are the forces? I've got a 24 newtons force minus my friction minus my mg sine theta minus my tension, and that is equal to MA. So 24, I do not know friction, minus 3,2, 9,8, sine 20. We do have our tension, 7,03. What is the mass? Doesn't even matter. It doesn't matter. All right, can we then walk through? Just get a calculator, please. Your own calculators too. It is 24 minus 3,2. All right, into bracket 9,8. I hope you're also doing yours. Sine 20. All right, minus 7,03. Yes, it makes sense for me to get a positive 6,24. All right, 6,24. So minus Fk plus 6,24 equals to 0. Minus Fk negative 6,24. My friction is now 6,24. But this is not the end of the answer. That is not what we are looking for. All right? That is not what we are looking for. We are looking for the coefficient. Oh, so what is the formula for coefficient of friction? Let's squeeze it here. Friction equals to mu k n. Let's take you back to our diagram. What is my normal force? My normal force is therefore equal to mg cos theta. I hope you see that. That we've done quite a couple of times. So this is mu k mg cos what? Theta. So what's our friction? 6,24. We don't know this. What is the mass? 3,2. What is g? 9,8 and cos what? 20. What do? We divide to get the coefficient. Calculator quickly. 6,24 divided by 3,2 times 9,8 cos 20. 0,21, and it has no unit. Why doesn't it have unit? I explained this in one of the classes. No unit. Why? It is a ratio of forces. Sweet 17 marks done. Feedback. All good? Just got one thumbs up there. Need feedback from you all. It's understandable. Google, you there? Let me know, everybody. All right, I've got a few more people. Let us know. All right, guys, I'm just going to... Okay, let's set 1,000 kilogram is orbiting the Earth at a distance of 200 kilometers from the surface of the Earth as shown. Be able to state that Newton's law of universal gravitation. All right, that's all in your notes. Calculate the magnitude that the force of the Earth exerts on the satellite. That's now basically what we did earlier on using F. F equals to G. So it is the mass of the Earth and mass of the satellite over the distance between them. G we know is a constant. Mass of the Earth is a constant. We know the mass of the satellite. Beautiful. 1,000. I think my focus will just be to tell you what to do with D. Please, for D, distance between their centers. Now you can see it's the measure from the center of the satellite. Please take note. We need to add the distance of the Earth to it, because the law says from their centers. From their centers. Very key. And that is the radius of the Earth, which is a constant. That's where the examiner wants to get you. The radius of the Earth. If you check your formula page, you'd find the radius of the Earth as a constant. So please, I'll leave you to do that, but you must please add that radius of the Earth. Let's see if I could pull out a formula page quickly. Let me see if I could pull out a formula page so that we see where to get that from. Let's see quickly. Let's pull out a formula page. Physics, resources, grade 11. Okay, let's pick something recent. So that you would see what we are referring to. There we go. So you would see the radius of the Earth there, 6,38. And then your G. So the examiner wants you to actually use 200. That's the aim. The aim is to get you to use 200, which is now wrong. Okay? I'm going to leave this here. So what is your D? Just going to, so you would substitute your D on the calculator and get your answer. D would be the radius of the Earth, 6,38 times 10 to the power 3 plus the distance we are given, 200. However, remember that this is all in kilometers. You must now multiply it by what? 1,000. to convert to meters. I hope this makes sense. We don't work in kilometers. Both of them are given in kilometers. You need to multiply by 1,000. But before you do that, you've got to add, and then you substitute. So we have our D. We can get the F. Sweet. All right. Calculate the weight of the satellite on the Earth's surface. Calculate the weight. We know how to calculate the weight, right? It's M times G. You have your M and you have the G. The same satellite is now orbiting the Earth at a distance twice the radius of the Earth. Okay? The same satellite is now orbiting the Earth at a distance twice the radius of the Earth from the center of the Earth. Without any further calculations, determine the force that the Earth exerts at a new distance. Let me quickly show you how to work around that. Please watch this. It's multiple choice. F equals to G M1 M2 over R squared. Right. Now, when the distance is doubled, let's see what happens. When distance is doubled, this is how we deal with it. F new. All right, because it will then change. Remember, it will be smaller. My distance is now 2r, all what? Squared. I hope that makes sense. Distance is doubled. So what am I going to have? G M1 M2 over 4r squared. And this can be written as 1 over 4 multiplied by GM1 GM2 over r squared. Do you see that? That's the mathematics. Now, what is this? It's F. Oh, so F new then becomes 1 over 4 of F old. You would see that a lot in multiple choice. Distance is doubled, distance is half. The same thing applies on electrostatics. Exactly same story. Same story. Everybody okay there? So you can just complete that whole calculation, but I've done all the work that needs to be done for you to be able to do the calculation. Don't forget, the law says the distance is from the center of the objects. Let's see, what do we have left? Okay, I think this is the last one on forces. Then I just do 2 on electrostatics. A pulley system is used to keep a crate of mass M stationary. On the diagram below, define the term resultant vector, a single vector that has the effect of 2 or more other vectors. All right. Calculate the vertical and horizontal component of T2. Oh, that's so easy peasy. Now we know what to do. I'm just going to do that quickly there, but I won't finish because of our time. That is there. And we know the angle as 30 degrees. But what is the force? The force is 245 newtons. They just want to deceive you by pulling it downward. Now, if I were to complete my diagram, you know how we roll. Vertical will be there, all right, and horizontal will be there. The one facing, this is Fy or Ty, and this is Tx. The one opposite, we use what? Sine. So 245 sine 30, and this is 245 cos 30 newtons. Just give the final answer there. Calculate magnitude of M1. Oh, let's draw a free body since the object is stationary. Ty, the weight, Tx, and T1. T1, Tx, Fg, which is mg, and this is what? Ty. y. Since the object is stationary, it means T1 is equal to Tx, and that is 245 cos what? 30 degrees. We're done. Just write the answer. Ty is equal to mg, because we need to calculate the mass. Oh, we're done. What is Ty? 245, which is 125,5 sine 30 equals to mg. Upward forces are equal, and horizontal opposite forces are also equal. By the way, I do know my g as 9,8. I'm sure now we can get the mass, and your answer is in kilograms. Simple stuff here, guys. Key is always in your free body diagram. Key is always in the free body diagram. You get that right, life is sweet. Okay, 11 marks in the bag. And should they ask you to draw, you know how to use your mathematical set. We just use scale to draw. Okay, everybody, that was that. Let's see 2 questions on electrostatics. Okay, I've got this with a string, and I'll look at this. All right, let's see. 2 positively charged identical metal spheres, A and B, each with mass of 4 kg, are suspended from the same point by lighting extensible strings of equal length. The strings makes an angle of 10 degrees with each other as shown in the diagram below. State Coulomb's law. Again, it's in your notes from school textbooks and all over the place. All right. Similar to universal gravitation, the force of attraction between 2 objects is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. This one is not their centers. That's the difference. This one is between them, not centers. All right. Draw a labeled free body diagram of the forces acting on B. Oh, sweet. Forces acting on B. There's a rope. So we have a tension. Okay? I hope that makes sense. Now, what do you notice? They are both positive, so they are repelling. So A is actually pushing B to the side. That is with an electrostatic what? Force. All right? Electrostatic force. We just call it Fe. But then it's an object, a charged metal sphere. It must have a weight. And that is your weight, Fg, which is equal to mg. That's your free body diagram. Please let me know if this free body diagram is okay. Why this way? It's repulsion. Please talk to me. I need to get you repulsion. Both of them are positive. So they repel each other. Free body diagram is key to everything in physics. Calculate the magnitude of the electrostatic force of repulsion between A and B. Let's see. Now, what comes to your head quickly is to say F equals to K Q1 Q2 over R squared. But are you aware we do not have R squared? That's a problem. Now, what do we do? Again, just like we've been doing in Newton's law, my dear learners, resolve these forces. Fe, what do we have? Fg, what do we have? Ty or Tx, and we have what? Ty. Ty, Tx is on that side. Fe is on that side. And what is this? Weight. Fg. Again, vertical forces are going to be equal. And Tx will be equal to your electrostatic force. Oh, so the question says calculate the magnitude of the electrostatic force. Just get Tx. Can you resolve? The question, that's the question. Can we resolve? This is this way. All right, Tx. And this is what? Ty. Let me help you here. Ty, Tx. All right, so this is what we will do. If we do that, because we must get that angle between them, all right? So the strings make an angle of 10 degrees with each other, which means because they are of equal length, exactly halfway would therefore be 5 degrees. Interesting. Now, do you notice this time around that TX is opposite the angle? 5 degrees. Does that make sense? And if it's opposite, what do we use? We use what? Cos. No, sine. We use sine. So this is going to be T sine 5, while this is T cos 5. But does that still allow us, because we don't even know tension? Do you see? We don't know tension. Now, since I don't know tension, I've got to look around to see what I can do. But Ty is equal to Fg. Don't forget those equations that we have. Ty, let me write it here quickly. Ty is equal to what? Fg. What is my Ty? T cos 5. Lovely. T cos 5 equals to what? Mg. Oh, what is M? By the way, T is, what is our mass? 4 grams, which must be converted to kilograms, divided by 1,000. 0,004. All right? Times 9,8 over. We are now done. So what is Fe? Fe is Tx. And what is Tx? T sine 5. What is our, so Fe, what's our T? 0,004 times 9,8 over cos 5 multiplied by sine 5. You get your answer there? That's your electrostatic force. Again, it's all about free body and all of that. Now with this, F being equals to K, Q1, Q2 over R squared. We now know our F. K is a constant. We know Q1, we know Q2, we can get R. Note, don't substitute with signs when you do these calculations. The signs just only tell you whether they are whether they are it's an attractive force or a repulsion. Please talk to me. Did this make sense? It's just about free body diagrams, guys. Free body all the time. Free body. You draw, you resolve, you calculate. Draw, resolve, calculate. Draw, resolve, and calculate. Any question here? Please let me know. Any question here? Any question? I'm waiting for your response. Please talk to me before I move. The only thing was that I didn't calculate, but all the steps are in. We just put the figures. So it's all in your free body what? Diagram. It's all in the free body diagram. Sweet, Ciclia and Google. Lovely. Rest of the people in the house. It's all in. So once you get your free body diagram correct, guys, the whole story is then done. Resolve the free body, check which forces are equal, check which forces are not equal, and we're done. All right, let's see this one. The spheres are now brought together into contact with each other and allowed to separate, making a new angle theta between them as shown. Sketch the combined field pattern. All right, what happens when charges are brought together? Number one, this is grade 10. Electrons move from where they are more. Electrons move from where they are more. to less. Number 2, both spheres will have the same charge. Will have the same charge. Hence, repulsion. They will repel. And how do we get that? Q nu will be equal to Q1 plus Q2 over 2. And number 3 is to calculate the number of electrons transferred, which is Q over QE. Actually, the Q here will be Q new minus Q old over the charge on an electron. And if you get a negative, negative N simply means electrons are lost. If you get a positive number of electrons, it means electrons are gained. Let's just check something quickly because I've answered the whole thing here. Which one has more electrons? That's what we're going to look at. Plus 1 times 10 to the power negative 6 or plus 9 times 10 to the power negative 6. This is plus 1 times 10 to the power negative 6 plus 9. The one that is closer to the negative has more electrons. This one has more electrons. Please take note. It is closer. The more negative an object is, the more electrons it has. So where electrons transfer from A to B or B to A, it's A to B. How do you get the new charge? I've given you the formula. Q new is to Q1 plus Q2 over 2. And both of them would have the same. How do you calculate the number of electrons? N equals to Q over QE. Q new, just pick either A or B. You don't have to do both of them. So Q new of A minus the Q old divided by that, and we're done. And I'm sure you can draw the attraction and repulsion. If it's repelling, then it goes almost like the diagram of a kidney. All right. Both of them would be positive because Q1 plus Q2, that's 10 divided by 2. They will both have positive 5. I hope you know how I got that right. I've just done the math. Positive means charges are leaving because they are both going to be positive. This is grade 10. Okay. It's important to put the arrows. Without the arrow, you get a negative 1. Arrows must not touch each other. They are parallel to each other. Guys, that's done. You just need to put the values. I've answered 7.5, 7.6 is point number 2. Where electrons transferred, electrons are transferred from where they are more to where they are less, point number 1. Determine the number of electrons transferred. Okay, let me just show you a substitution there. This would be equal to, what is our Q new? Positive 5 times 10 to the power negative 6 minus Q old. Choose any one of them. 1 times 10 to the power negative 6 over negative 1,6. The negative, there is the charge on an electron. All right? Charge on an electron. Charge on an electron, and it is a constant. You will also see it in your formula page. I am done with that. Easy peasy, 21 marks again. All right, so that's a short summary on electrostatics. Let's answer the last one for the day. But I hope it's been helpful so far as you prepare for your term 1 test. Let's try to solve the whole of this one. Two identical point charges are placed 100 millimeters. That's my first call of duty. We don't work in millimeters. All right? So what do? We divide by 1,000. If it's centimeters, we divide by 100. All right? Placed in the vacuum as shown below, the electrostatic force Q1 exerts on Q2 is 5,09. Beautiful. Draw the electric field pattern between the two charges. It's exactly what we drew the other time. They are repelling. All right? It's repulsion. It's the same diagram that we have there. Calculate the magnitude of each charge. All right, let's see. It says they are identical. So F equals to K, Q1, Q2. Because they are squared. Because they are identical, Q1 is equal to Q2. So what do we have? 5,09. Now again, on your formula page, let's show you where you get your K from. Do you see there? Coulomb's constant, 9 times 10 to the power 9. Please use your formula page. All right? 9 times 10 to the power 9. This is Q squared because they have the same, it's identical. Now, what will this be? 100 divided by 1,000 will give us 0,1. Sweet learners, I'm sure you can get an answer from here. Let's see. What would we do? It's 5,09 times 0,1 squared. Please don't forget the squared. Learners to forget. Now, all of this, please use this button for division. Don't say the normal division because you could get things wrong. But I have to then find the square root of that. That is the charge on an electron, on each of them. 2,38 times 10 to the power negative 6 times 10 to the power n. What is our unit? Coulombs. I hope that makes sense, everybody. So it's as simple as that. Okay, let's do the last one. 8.3 and 8.4. Calculate the net electric... Oh, no, I think there's one more because I want to do something with a right angle before I leave you. Calculate the net electric field. Guys, net electric field at point P. All right, point charges are positive. Point charges are positive, except they tell you it's an electron. All right, calculate the net. 5 marks. Beautiful, 5 marks. Check what I'm going to do. I start by drawing a free body what? Diagram. We draw a quick free body diagram at P. Okay, so that's my P there. P is positive, remember? Point charges are positive except when told it's an electron. Now, between Q2 and P1, Q2 is positive, P1 is positive, it's repelling. Okay, so it's going to be in that direction. We are focused on P, my dear learners. Oops, I don't like that color. We are focused on P. I'll call this E2. Now, what about Q1? Q1 is also positive again. So, guys, we are looking at this on that, and we are looking at this because the examiner says at point P. Oh, it's also positive. Ah, sweet. So, also in that direction because it's repelling P, E1. Take right as positive. We go back to our vectors. Now, what is E net? So, since right is positive and both of them are positive, E1 plus what? E2. Oh, lovely. What is E? It is K Q1 over R squared. E2, K Q2 over R squared. 9 times 10 to the power 9. What's our Q1? Oh, we got Q1, 2,38 times 10 to the power negative 6. Now, here is where I must slow down. What is the distance between I'm working with Q1 and P, working with Q1, it is 150. But I need to divide by 1,000, which is 0.15. I hope that makes sense to you. Plus, not times, plus 9 times 10 to the power 9 times 2.36 times, here you trust your calculator, and the distance between Q2 and P is 50 meters, which is what, 0.05. You add that together and you are done. What would be your answer? Whatever you get, which is a positive, right? Whatever you get, Newton per coulombs to the right. Should you forget the formula, the unit in the exam, go back to your formula page. Your formula page also has it as E equals to F over Q. So it's Newton over coulomb, which is Newton per coulomb. It's a vector quantity, guys. So you are just the way you were doing Newton's laws. Okay. Let's see. Okay, I love this third one. Let me recreate a page and take you through 8.4. Let me take you through 8.4. I want us to see the difference between that. So Newton's universal gravitation and electrostatics are one and the same thing, only that one is dealing with charges and the other one is dealing with the bodies. Okay, this thing is refusing. I want to get 1 second. Guys, are we okay so far? I know you'd need time to assimilate all of this, but it's just revision. Okay? So I'm only showing you the ropes. If you get these ropes, you can answer as many other questions as possible. All right, so just want to get this. All right, that's what I want. I want page. There we go. Let me write, what's our Q1? 2.38 times 10 to the power negative 6. So 2.38 is positive times 10 to the power negative 6. Now, a third charge Q3 of 5 microcoulombs. What does that mean? All right, magnitude of 5. We also see that it's positive here. Negative 6 coulombs. If it's nano, it's 9. Calculate again. What are we looking for, my dear learners? Net electrostatic what? Force. Take note. Experienced by point what? Q2. Our focus is now on Q2. So we will then do this for this. But mind you, it is electrostatic force. Whatever we did for E is the same thing we're going to do for F. Free body diagram quickly first. But our focus is on Q2. What's going to happen? Q1 and Q2 will be pushed this way. It will repel. I'll call it F1. Q3 on Q2, it will be repelled this way. I'll call it F3. So, write as positive. F net will therefore be equal to F1 plus negative what? F3. Does that make sense? Which is F1 minus F3. Easy peasy. Now, what is F1? So once again, free body diagram is right. Life becomes easy. K. Q, I'm dealing with 1, right? Q1, Q2 over R squared minus K. I'm dealing with Q3 now. Q3, Q2, because our focus is on 2. 9 times 10 to the power 9. What is our Q1? 2,38 times 10 to the power. What is our Q2? Oh, our Q2 is the same. 10 to the power negative 6 over, what's our distance? 0,1 all squared minus, now what do we have here? 9 times, it's just a matter of now substituting. Q3, 5 times 10 to the power negative 6, 2,38 times 10 to the power negative 6 over, what is the distance? 0,05 all what? Squared. You get your answer. Psh. And now you would check if it is, because the examiner says net electrostatic force. You will then check if it's positive or negative. If it is positive, you chose right as positive. Remember, if it's positive, then your answer would be to the right. If it is negative, your answer would be to the left. It's been a long day. But did this make sense? Sitley TK? Gugu Ofente? So it's just me quickly putting everything into perspective. You just put in numbers and you walk through like that in any question. The last one, I need to make sure I do a right angle. Yeah, I really chose good questions. 3 charge spheres X, Y, and Z are placed perpendicular to each other as shown in the diagram below. Alright, state Coulomb's law. Done. Draw a labeled force diagram showing the directions of the electrostatic force, not field. Always take note of what we're doing. Alright? And the net force. That the charge sphere Y, our focus is on Y, experiences due to the presence of X and Z, our focus is on Y. Don't forget. Alright? Y is negative, so we're going to check X on Y, Z on Y. Okay, let's look at X. X is positive, Y is negative. Our focus is on Y, right? Y will be pulled towards X. There we go. It is electrostatic force, so it is Fx. We're done. Remember, you are simply asking yourself what happens to Y. Y is attracted towards X. What about Z? Z is negative. Oh, so Y is pushed away from Z. If it's pushed away, it's going to be like that. We're done there. Fz. So what's going to be my resultant? Sweet physics. It's at 90 degrees. So F what? Resultant. It is at 90. So calculate the magnitude of the net force. Since it's 90 degrees, we then bring in our theorem of Pythagoras. Our F res is our hypotenuse. Fz squared plus Fx. Sweet maths now. Now, what is the force of Z on Y? It is K. Don't forget all the formulas. QZ. We are focused on Y. When you're dealing with force, it's both Q's. And what's the distance? R squared plus K. Here I am now working with X, but our focus is on, no, not Z. Our focus is on Y still, right? Over R squared. Okay, you can do all the substitutions, all right? But remember, you have to find the square root. All your distances are there. You have K formula, you have QX. Remember, it is all micro, so it is times 10 to the power. You must change that, please, my dear learners. Times 10 to the power negative 6 columns, please. Change all of those, micro. Throw it in. The distance between QX, QZ, and Y, 0,3. So this one here is 0,3. While this one here between X and Z, X and Y, 0,4. Don't forget the squared. Oh, by the way, we are looking for the magnitude. So we don't need to get direction. But how do you get direction as I round up? My dear learners, watch what we have. We have that. Okay. We have that. That's our free body diagram. And we have that. So this is our what? Fx. And this is our Fy. You can calculate from the horizontal theta. And basically that's what? Again, Pythagoras SOHCAHTOA. This is Fx. Do you notice that is opposite? And this is what? Adjacent. So tan theta is opposite Fx over Fy. You get your angle there, theta. That is if the examiner wants direction. But in this case, they asked for magnitude. And that's how you walk through, guys. Whether it's linear, whether it's a 3D, which is your 90 degrees, same story. Please, free body diagram is the key. All right, so this was the question. These were all the questions I sent to you. I hope you can go through again and recalculate. I'll send you the slides. All right, just in a moment. You can re-look at the work again, redo the calculations, go through the concept again and the principles, and I'm sure you will be okay. All right, everybody, is that fine? Is that okay? Is that okay? All right, everybody. All good. Awesome. All right then. Good night, everybody. And yep, we will communicate on the group if there is any other question. All right, Gugu. Good night. You're welcome.